Hello everyone and welcome back to this next lecture. So in the previous lecture I had added the dead time to the pair of output pins which were given by that formula WOX and WOX plus WO num by 2. So I had already said that this means that there is a mapping between two pair of pins, that is WO0, WO4, WO1, WO5 and so on and so forth. Right? So in this lecture I'm going to execute the project and I'm going to verify that we do indeed get these dead times between the gating signals. And moreover, we want to also verify that we end up with complementary gating signals. Because now remember, we have removed the inversion that we had done using the driver control register. So with this, I'm going to bring the oscilloscope into the video. So with this, you can now see the oscilloscope, and now I will run this program. So I'm going to use production, make and program device. So you see now there is a waveform. So the waveform, as you can see, let's zoom in a little and you will very clearly see there is now a dead time, right? If we zoom in a little, you clearly see that the rising edge of this blue waveform is delayed after the falling edge of the yellow waveform, and vice versa as well. So for example, if I go all the way up here and I scroll, unfortunately this is how much my oscilloscope can do. So let us check another pair of waveforms. So this is the waveform between WO1 and WO4. I will now show you the result between WO2 and WO6. And let me connect WO6. And this is the connection. Let me just go up a little, and here you can see very clearly that there is a dead time in both cases. So there is a dead time here as well, where the blue waveform, the rising edge of the blue waveform, is delayed after the falling edge of the yellow waveform. Now I would recommend that you, after you make these changes, go ahead and verify this for all the pair of pins which I mentioned. Remember, the dead time is inserted only between those specified pair of pins. That means the pins that are constrained by that formula. You cannot insert the dead time between any random pair of pins. Once you use the dead time generator, you are constrained to use those particular pins only. So if you got these results, we have now been able to produce a practical PWM gating pulse which we can feed to an actual converter. Because remember, now not only are we able to set the frequency, we are able to set the modulation signal, we are also able to vary the pulse width. And last and most important, we are able to insert a dead time so that we do not short circuit our DC bus. So with this, I will end the oscilloscope video. And we are almost at the end of this lecture as well. And not only are we at the end of this lecture, we are almost at the end of this section as well. So with this, if you have any doubts, or you faced any issues, or you didn't get these results, please post in the Q&A forum. I will do my best to help you. Otherwise, I will see you in the next lecture, where I will slowly start wrapping up this particular section. Thank you so much for listening, and goodbye for now.